okay, soon. So why don't we graph this function, okay? So what if we were to graph this function? So I'm going to do this using the definition, okay? So kind of like what I did up there. So let's do that. So if I use the definition, then y is equals to, it stays the same, right? Just x minus 3, as long as x minus 3, right? Whatever you have inside happens to be positive, greater than or equal to 0. Um, and then if you solve for x, right, this is the same as saying or, as long as x is greater than or equals to 3, okay? And then I have to multiply x minus 3 by minus 1 if x minus 3 happens to be negative, right? If it's negative, then you have to multiply that minus 1. Um, and this is the same as saying or when x is less than 3, okay? So basically, it's the same number. You just have to flip your inequality. Again, I've showed you this last week. So these are your two functions that you have to graph. When you're using the definition, I guess, you know, if there is no plus something or minus something, you can think of this as your x-intercept. Okay, so this is kind of like your x-intercept. Um, in the case of both linear functions, and I'll talk about that a little later. Okay, so let's focus on this function. Let's be consistent with our colors. Okay, so let's focus about this function. Let's focus on this function in purple. So how would you graph this function? The function is y is equals to, right? In purple, your function is just, I need to graph this function. Y is equals to x minus 3, okay? And again, that's not difficult, right? It's just a question of understanding that your y-intercept is negative 3 and your slope is 1. So your function should be increasing. And by increasing, I mean your function is rising as your x values are increasing, okay? So basically, this function looks like, I'm going to start off at minus 3, right? And my function is increasing. So remember, my x-intercept happens to be at 3. And you can kind of convince yourself just by doing this, right? So if I plug in, so in this function, if I plug in x is equals to 3, my y value will be 0, right? So this is the x-intercept. Now you see this function is only defined for when x is greater than or equals to 3. So this is the if you want, this is the x value of 3. So that means this, I need to get rid of this piece over here, okay? And this, what do I mean? Hold on, let me show you which piece. This needs to disappear because my function is only defined for when x is greater than 3, okay? So I'm gonna remove this piece. And this is what my function in purple will look like, okay? Because it cannot exist for the x values that are less than 3, okay? Based on the domain that's given to me up here. Okay, now I need to graph this function. And this one, I'm going to do this in green to be consistent. Okay, so this is your function y. Let me just write this over here. Y is equals to minus x minus 3. So just, again, you want this in the form y is equals to mx plus b so that it's easier. So why don't we distribute the minus 1? When you do that, you're going to get minus x plus 3, okay? So this function has a slope of negative 1, y-intercept of 3. So starts at 3, right? Y-intercept. And then because the slope is negative, your function will decrease as your x value increases. Actually, let me do this way. And it will have the same x-intercept, okay? It will have the same x-intercept. So this is what the function looks like. I'm talking about this function over here. But this function has a domain, okay? This function only exists when your x values are less than 3. So only for all the x values less than 3. So that means this piece over here needs to disappear, okay? Sorry. So I'm going to remove that piece. So let's remove this piece, okay? And this is what the function looks like, okay? So the function in purple, x minus 3, just a linear function, but only the domain of this function is x has to be It's kind of hard. Let me just zoom in and let's delete this. It's kind of annoying. Okay, so I'm just gonna, oops, get rid of this and then rewrite this. So the function in purple, right, is your function x minus 3. Only it's only defined for when your x values are greater than or equal, so this should be a 3. Okay, greater than or equal to 3. Why is it 3? Because I solved this inequality in terms of x. Okay, so using this, I know that x has to be, which is what I have over here. Okay, so this is, it's kind of complicated because I'm using the definition. Now, what's the best way to graph this, in my opinion? So I'm going to show you a second